Are we having fun? I think what I love so much about being here is everyone's passion. My passion is really fueled by a fundamental asymmetry that I feel a bit existentially when I look at our night sky. I think we've all been there. You look up, you see thousands of stars, and we now know there's billions of stars that we just can't see. And each one of those has planets around it. Yet we don't know that any of them have life. As far as we know, at this moment in time, we are on the only inhabited planet in the entire universe. We hope there's life out there, but we don't know. Life on this planet first emerged 4 billion years ago. The earliest life we know about was microbial. And since it first emerged, it's been expanding and generating all of the structure around us. Everything in this room is a product of life. Although life has been here for 4 billion years, we've been doing this remarkable thing we call science only for a few hundred. My discipline, at least my original discipline, is theoretical physics. I love thinking deeply and abstractly about the nature of reality. And our first generations that we started to do that did something very profound. They discovered the idea of universal laws. We all know about gravity, right? We've been experiencing it for as long as humans have been here, longer, if we think back to our microbial ancestors. But until the generation that started to think about universal laws, we had no conception that the reason that we're all stuck here on this earth is the same reason that we see wandering stars in our night sky or see the large-scale structure of the universe as we look out. Universal laws are incredibly powerful because they allow us to not just talk about phenomena here on Earth, they allow us to talk about universal physics and what can exist, what could be potentially exist. This idea deeply intrigues me. I mean, even though we've been experiencing life, we are life. I think everybody in here is alive. We actually don't have a universal understanding of what life is. So just like we've experienced gravity, we can articulate it now with universal laws. We can't do the same thing with life. So this raises a fundamental question. What is life? I spent my entire career trying to answer this question, and I think it actually requires fundamentally new physics. Laws of physics we have yet to discover. With my colleagues, I'm developing a new approach to this called assembly theory, and we hope that assembly theory will offer the first universal laws of life. The idea that we're exploring is quite simple. It's that life is the only mechanism the universe has to generate complex objects at scale. The everyday objects of our experience, everything from molecules to moons, are generated by living things on this planet. The question we're asking is, how could we know if we looked at any object in the universe it was a product of life? To do this, we have two simple ways of formalizing it. We talk about assembly index and copy number. Assembly index is taking an object, breaking it down to its basic units, and looking at the minimum, shortest path to build that object, starting with reusing the parts. Copy number is just how many of it you find. Now, this is a bit abstract, as most theoretical physics is, so I'll tell you with a simple example, one of my favorites, the little black dress. A wonderfully designed object. Coco Chanel is absolutely brilliant. Lots of copies of this object on our planet. If you think about the construction and design that goes into that dress, we think it's very simple, but it's actually a very complex object. And in assembly theory, we would formalize it by saying stitches are basic units. And you can reuse the stitches, and you can reuse parts to assemble garments by building swatches of fabric and then assembling them together. I love fashion, but I love fundamental science even more. So let's apply the same idea and actually get in the lab and see if we can measure life. We did this. We actually took molecules. We figured out how can we measure this kind of complexity, this constructed complexity, the design in the object that evolution, our learning, produces, and measure it as a feature of molecules. And when you do this, it turns out, if you take abiotic samples, non-biological things, we had some blinded samples from NASA and some living things, there is a complexity threshold, a minimum assembly index, turns out it's about 15, above which you only see molecules produced by life. So we've invented a way to measure life. And in the history of physics, when you have new measuring techniques and new standardized ways of talking about phenomena, it allows you to invent new theories and new ideas. And I'm incredibly excited about where we can apply this. One of the first places that we're thinking about, besides the search for life in the solar system, is thinking about the search for life on exoplanets. So each of those stars in our night sky has planets around it. We don't know that there's life there. But now we have a way of actually measuring it. And whereas we can detect life in a single molecule, we can actually also detect it in the set of molecules that make up a planetary atmosphere system. We do this by using the infrared light, the light that we actually get from the planet, which reveals the complexity of the molecules in the atmosphere, and can use this to directly measure this property of the assembly index of an entire planet. We apply this to a bunch of atmospheres, and I was so excited because Earth just popped out. We're on a very complex planet, very nice. But the idea is that we will actually be able to apply this to look for complex life on very distant worlds with direct detection in infrared. Hopefully somebody will build a telescope that allows us to do that. It's a tough challenge. The other place I'm incredibly excited about applying these ideas, actually there's a lot of exciting things, is thinking about experiments to look for alien life here on Earth in the lab. In some sense, I'm arguing life is about the physics of creativity in the universe. It's about novelty and the reproduction of novelty. I want to build experiments that allow us to understand how planetary geochemistry leads to evolutionary design without us putting the design in. If we can do this, I think we can fundamentally discover new laws of physics. And we might be the first generation in 4 billion years of evolution of life on this planet that comes to understand what life is, what we are.